In this video, we're going to talk about the different principles of statistical hypothesis testing. So far, these are what we've had talked about. We first talked about descriptive statistics, but as the name implies, they are mere description of the sample only. That's the given mean is this. That's it. The given standard deviation is this. That's it. And then we would go to probability. Given the descriptives, we can then usually find the probability, but it's often theoretical because it's a probability. We don't know unless the event actually happens. We just get an idea of how big or small the chance is, but that's a theoretical perspective. We don't know unless it actually happens. Now, we can combine these two so that we can estimate certain values of the population from the sample, but we cannot prove or disprove anything. What we have is simply, would simply be an actual statement of where sample values or where the population value is. Basically, that would be it. So now, we're now going to do a hypothesis test. This is actually one of the highlights of inferential statistics. This is a procedure that tests a certain assumption or hypothesis about the population using sample data, hence hypothesis test. We're going to test a hypothesis based from sample data, but the hypothesis is about the population. And it is guided by the previous topics that we had: descriptive statistics, probabilities, and sometimes point estimates. So we have this initial assumption that we have, and we're going to either reject or not reject it given a certain probability. Now, the assumption, or not the assumption, but the assumption wherein there is equality, the claim of equality, we have that null hypothesis. Now, the counter hypothesis for that would be what is called as the alternative hypothesis. Now, although most of the time, the books would define the initial assumption or claim as the null hypothesis, it depends on the problem whether it is actually the null or the alternative. Why is that? Because the null hypothesis should always involve signs with equality. It's either equal, less than or equal to, or greater than or equal to. The alternative hypothesis would involve the inequality symbols greater than, less than, or not equal. And if the claim in the problem would involve these expressions, then the claim is HA, not HO. Now, in our case, in hypothesis testing rather, what we try to test is either we reject or not reject, or what we usually say is we fail to reject HO at a certain probability. But remember, we either reject or fail to reject, but we never accept whether the null hypothesis, we never accept a null hypothesis. Why is that? What is the difference between whether you reject, or you fail to reject? Now, we can liken this as if we are in court, wherein if the null hypothesis is rejected, this is considered as guilty. But fail to reject is considered not guilty. But remember, being said that you're not guilty, that does not equate to innocence. That does not equate to innocence, because you might have done the crime. It's just that there is no sufficient evidence for us to say that the crime has been done. Similarly, there might be no sufficient evidence for us to reject. That's why the term is we have failed to reject. because we don't have sufficient evidence to reject HO. And if HO is rejected, then we don't have a choice but to conclude with HA. If HO is not rejected, then we conclude with HO. Take note, we conclude, we don't say we accept. We only conclude that based on these evidence, based on this pieces of evidence, we either reject or we fail to reject the null hypothesis about the population based on sample data. Now, one important thing about the alternative hypothesis is that this would tell us the direction of the hypothesis, which is important in the steps that we follow. Now, we have three different directions when we talk about the directions of a hypothesis test. We have one tail upper tail, one tail lower tail, and a two-tail test. So, this would actually depend on the symbol of the alternative hypothesis or HA. Take note, if the alternative hypothesis is that it's greater than, then the direction is one tail upper tail. And obviously, the opposite of greater than is less than or equal to, and that is our HO. If HA is less than, that means the direction is one tail lower tail. So if it's greater, it's upper tail. If it's less than, it's lower tail. And the opposite of less than, which is greater than or equal to, becomes HO. Now, the third one is two-tailed because it doesn't say whether one is bigger or not. It only says that the population mean is not equal to mu sub 0, which is the hypothesized value of the population parameter, which can be the sample mean. So, it doesn't say one is bigger than the other, just says that it's not equal, hence we have a two-tailed test. Now, we don't just test whether the population mean is equal to the sample mean or the hypothesis mean. We also test proportion. That's why we have P here. And we also test D. This actually stands for difference. Later on, not later on, but in the upcoming lessons, we're going to talk about whether the mean of one group is equal to the mean of the other group. And if they're equal, then their difference should be 0. Although there will be cases that we want to know whether the hypothesized difference is equal to a certain number, most of the time it's whether or not the difference is equal to 0 or not, meaning are they equal or not. Now, there are also some other hypotheses like this, although it's kind of difficult to write in equation or in mathematical expression. Now, for example, we are asked whether all means or proportions are equal. We might be comparing, let's say, for example, three or more means. Let's say, I'll use this. 3 means. Now, if all means are equal, then as is, all means are equal. That's your null. However, if it's just mean 1 that is not equal to mean 2, but mean 2 is equal to mean 3, then that's already an alternative because not all the means are equal. Remember that HA, everything has to be about equality. That's why we have that. Now, we also have this, which we're going to encounter in the future, whether as X increases, will Y not be affected, or as X increases, Y will either increase or Y will either decrease. Now, one important skill in hypothesis testing is writing what is HO and HA given certain situations. Let's have examples of those. We have the first one. If a hospital assumes that they can discharge their patient in less than a week on average, and you'd like to prove this, we're asked to write the HO, HA, and then determine the direction. So, the first thing to do is to check what is the claim. What is the claim of the problem? And we say here that an hospital assumes, so that's the claim, the hospital assumes that they can discharge their patients in less than a week on average. Less than a week on average. So that's their claim. So if we're going to have a week as 7 days, then they're claiming that on average the average is that it's less than 7 days. And well, it's pretty straightforward that this is the symbol, hence the claim of this is that their average is less than 7 days. Since the claim is less than, it doesn't have any equality symbol, then the claim of number 1 is the alternative hypothesis, that their HA is that the mean is less than 7 days. Hence, the other one that we need to write is the opposite of this, which is the null hypothesis, where the mean is greater than or equal to 7 days. This is what we're saying, that although books would always say that the initial assumption is the null hypothesis, sometimes it's actually the alternative hypothesis. So, how do we write again our H or HA? First, identify the claim in the problem. Then, based on the claim, write mathematically whether it involves an equality or not. If it involves equality, that's HO. If it does not, then it's H. Pause the video and try to see whether you can write. Before you do that, we need to also determine the direction. Now, the direction is based on the symbol of HA. Since the claim of which is the HA is less than, then the direction of this, it's less than. So that's one tail. And making it less than, that's a one tail, lower tail. There you go. Now, pause the video and try to see if you'll be able to write the HO, HA, and the direction for numbers 2, 3, and 4. Alright, so let's see. The first here is that it's easy to see the claim in number 2. The supermarket claims that at least 95% of their products on display are not expired. So, if you remember from algebra, at least would mean, here you go, at least would mean greater than or equal to. So, their claim, based from this, is that this is proportion because that's a percent. So, the proportion is greater than or equal to 95% or 0.95. Since it involves equality, then this time in number 2, the claim is HO. That the proportion is greater than or equal to 95%. Making the HA, the proportion is less than 95%. And since the symbol of HA is less than again, therefore, this direction would be one tail lower tail west. Now, in number 3, they have this claim that the company claims that there is 10 milligrams of loratadine. Now, it doesn't say one is bigger, one is not bigger. It just says that there is. Since there is, therefore, on average, you can say that the mean is 10 milligrams. Remember, most of the time when you say is, it's equal to in algebra. So the claim is that the mean is equal to 10 milligrams. That's why, and since it's equal, that would be our HO. The mean is equal to 10 milligrams. Making the HA, since it's just equal, the HA should be the mean is not equal to 10 milligrams. And since it's not equal here, hence the direction would be a two-tailed test. In number 4, we would have it here. Department A claims that the means, let's change color. The claims that the mean satisfactory level of their employees in A is higher than that of Department B. So, the claim, I'll just write it here. The claim is that the mean satisfaction in A is higher than of P. And since it's higher, it should be greater than. This makes it HA. So I'll just write it here. The HA is that the mean of A is greater than mean of B. Making its HO, the mean of A is either less than or equal to the mean of B. And with this, it's greater than, therefore this direction, the direction would be one tail, upper tail. So that's how we write now the alternative hypothesis, which would be very important in hypothesis statement.